Good morning. I'm Margie O'Driscoll, and on behalf of the Center for Innovation's Board of Directors, I'd like to welcome you to today's webinar. The mission of the center is to reshape the architecture, engineering, and construction industry for a better tomorrow. So thank you for joining us on this journey. We'd like to take a moment to express our gratitude to the many sponsors who make our work possible. Thank you. The Center for Innovation recently concluded our fall forum, which included talks with people charged with rebuilding the Ukraine, the Bosch innovation story, and a deep dive with several building owners about their view of innovation in 2050. If you missed any of these webinars, please check out all of our webinars on our YouTube channel. It's now my pleasure to introduce you to today's speaker, Phil Bernstein. Phil has just published this book called Architecture in the Age of Artificial Intelligence. Phil sent me a copy this summer, and I told him I plan to read it on the beach to make me look smarter. In case you were wondering, I looked a lot smarter. I did read the book, and as I recommend you all do, it's a deep dive into the opportunities of AI to shift the world of architecture and design. Today, Phil will explore how big data and machine learning might change the structure and approach of design practice, exploring both the opportunities for performative improvement and threats to the agency of architects. He poses a question we've all considered. What strategies might design professionals adopt to take maximum advantage of new technology? Here's a little bit about Phil. He is a fellow at the American Institute of Architects. He's also the Associate Dean and Adjunct Professor at the Yale School of Architecture, where he teaches classes in professional practice, project delivery, and technology. He's a former vice president at Autodesk, where he helped develop and lead the company's transition to BIM. Prior to Autodesk, Phil was a principal at Pelly Clark and Partners Architects, where he managed some of the firm's most complex commissions. Welcome, Phil.
Thanks, Margie. And I'm impressed that you took a book with a black cover onto the beach.
Sure. Anything to look cool, just saying.
I can recommend a couple of novels for next vacation. And thank you guys for the opportunity to talk about this little project I've been working on. Those of you who follow some of my work know that I am really interested in questions of how technology changes the relationships of the players in the building industry, and particularly the value propositions of those kinds of relationships. So there's been a lot of thinking and a lot of talking about the implications of artificial intelligence for society and for the building industry. I find most of it not really super interesting myself, and I'm gonna build an argument today for how I think we in the building industry might want to do so, particularly through the lens of designers and architects, because I am an architect and I teach architects. And so I want to suggest the following construct about what role designers play in the formulation of built assets. And what I argue in the book and with my students is that there are really four of these roles. We protect the public's health and safety. We act as agents on behalf of owners. We guide contractors to translate design intent into construction execution. And we run these teams that execute these projects. And we do so under this umbrella legal concept called the standard of care. It's essentially a competency standard. And that standard of care comes with a series of risks that each of these relationships has responsibilities and risks. And one of the questions that we'll talk about today is, what's the relationship between the advent of technology, the agency of the players in the process, and the risks and rewards that they may take on in each one of these roles? And the risks are different. Now, this question of professional competence or the standard of care, or what it is that we as designers do in this system, has certain kinds of existential qualities. And my former colleague at Harvard, Victoria Beach, wrote in the latest version of the AIA handbook, she said, expecting an architect to design a safe structure is like expecting a chef to cook a safe meal. It is at once a high ethical requirement and a very low expectation. And then she goes on to argue that aesthetics are probably the solution to that problem. This is where I depart from Victoria's thinking here, because I actually don't think aesthetics are the answer. I think there are some other issues that we have to deal with. And so we'll stipulate, of course, that we'll stipulate with this one slide all the structural problems of the building industry. This is from the 2014 Smart Market Report, that basically where owners and architects and contractors all agree that our projects are beset with challenges. We'll kind of stipulate that. That's all kind of inside baseball. And I think in order to address this question in the context of the potential potency of next generation technologies, we have to actually think about the problem in a different way. So there's life safety, and then there's life safety. This was, if you haven't read this Grenfell report about the towers that burned in London, you should do so. It's an incredible indictment of the systems that we use to build buildings. Failures at every level to understand systemically how design and construction decisions yielded a circumstance where 84 people burned to death when a refrigerator caught fire, and no one had proximate responsibility for the problem. So life safety is certainly front and center. Climate change and embodied carbon, obviously a problem that we're all thinking about and are trying to deploy tools to look at. This carbon issue, though, is more than just, for example, this tool by Karen Timberlake that analyzes embodied carbon in a design. It's more about systemically and systematically understanding how things flow through the systems that ultimately yield buildings. This is work by my colleague here at Yale, Alan Organsky, who studies the circular carbon economy and works on this thesis that buildings can be storage mechanisms for carbon that is transmitted through essentially through mass timber. And the problem set is getting much more challenging, I think. This is how I spent the summer of 2020 with a team here trying to figure out how we were going to run our School of Architecture during the pandemic, which was essentially a public health meets spatial and sequence planning exercise. A lot of interest these days, especially among the younger generation, about the relationship between the structure of the environment and environmental justice, and how the buildings that we build and the cities that we build reify certain kinds of inequity. I'm doing some research with a team here at Yale, and I'll talk about that in a little more detail later, on modern slavery in the building industry. There are 18 million people in the world enslaved doing things related to the built environment, which is becomes a different kind of social justice issue. For example, this is how we explain that problem to our students. This is a diagram that I use to explain how your decision with your construction manager and your client to build a steel building enslaves this worker who is harvesting trees in Brazil to supply charcoal for the smelters that create the steel in your building. And you can see here, this is a systemic analysis problem because there's 10 steps between you and that enslaved worker. And how do we as designers and as builders begin to see these problems more coherently? Now, there's an immediate instinct to think that technology is really the solution to this problem, and really technologies, 2 or 3 technologies have really transformed the possibilities in the building industry, because we work on very large data intensive things. And those technologies include the cloud, which allows you to do all your heavy compute work someplace off your desktop or the job site. The internet, which allows you to deliver that information to the point of work, and substantial kinds of mobile devices, which allow essentially information to be distributed widely across the enterprise. And Jesse Devitt, who runs a venture capital group that invests in build tech, has used a version of this taxonomy to look at all the different kinds of technologies that are out there that seem to be emerging in the last 5 to 7 years, whether it's modeling tools or robotics or computer vision, electric vehicles, and then kind of enablers like blockchain. There's a lot of stuff going on out there right now. And that amount of stuff that's enabled by these kinds of technologies like the cloud, I think are bringing us to a certain historical moment in the evolution of our use of technology in the building industry, which leads to my argument about AI. So in a sense, you can look at that history, at least in my view, in 5 discrete steps. For thousands of years, we drew things on pieces of paper. Then we drew things on pieces of paper using computers. Then we started using computers to make 3-dimensional models of the artifacts, the assets that we're trying to build. But now, given all that stuff I just showed you, we're about to enter into what I call the digital interregnum, which is the intensive and largely disorganized digitization of many heterogeneous processes in the building industry. And as you'll recall, and I wrote about this in my first book, Architecture Design Data, the original thesis was that building information modeling was going to create this lovely, harmonious, coherent flow of information that started in design, transited into construction, eventually became available as part of building operation. And then all of that data would reinforce our knowledge in the next cycle. But what's really happened in my view, and this is probably one of the great disappointments of my career as a technologist, before I retreated to the academy here, is building information modeling has largely failed to deliver on its promise of that diagram. You know, I love this BIM image from DPR that I've been using for years, because it symbolizes to me the hope and aspiration of building information modeling. You look at an image like that and you say, damn, these guys must really know how this building goes together. This thing's been modeled within an inch of its life. It's obviously all the way thought out. The systems are understood. It's perfectly coherent, and it's going great. But in fact, what has happened with BIM, which I think is largely a failure of nerve of our industry writ large, is that what's BIM is really used to do is the image on the right, generate working drawings faster. So we've essentially taken the next generation of technology and used it in a way that is completely coherent to the first several thousand years of our use of technology. I find this highly problematic, but an opportunity to learn some lessons for how we might move forward. So what I argue in my book is that we're in the middle of this data interstice, this interregnum, where levels of information precision and degrees of automation of the process, which are really the 2 opportunities of technology, do things more precisely and do things more automatically, have been slowly increasing as we've moved from hand drawing to BIM. We'll go into this period of disorganized oscillation for the next few years while we try to figure out some way of cohering things. But that artificial intelligence and machine learning, which are ways that machines assert understanding, are strategies for how we might get to some kind of information coherence. And that is a good news and a bad news proposition, and that's the one that I want to argue. Now, if we're in the data interstice right now, then what we're going to talk about, at least till the end of my slide deck, is this transition into machine learning going forward. Now, just totally coincidentally, I stumbled into this entire enterprise decades ago when I was a sophomore in college in 1975, because I had taken the Introduction to Computer Science course here at Yale, and the next course that I signed up to take was computer graphics. And computer graphics looked to be the right thing for a young architecture student to take, but we were going to spend several weeks learning how to draw circles on oscilloscopes, which bored me tremendously. So there was this guy named Roger Schenck, who turned out to be one of the forefathers of natural language artificial intelligence, doing work here at Yale. So I started taking courses from him. And we did stuff like this. Roger had a theory of fundamental knowledge representation that he called conceptual dependency theory. And then we, his students, would write these scripts to do things. You see a script down below for going to a restaurant. I wrote a script for my final project to understand oil tankers. We were working on these machines called PDP 1145s. There's a picture of it on the right. One day I was working away in the Yale Computer Lab. There were like 12 of us working on one of these little machines and it exploded into flames. So it was kind of stressed out doing all this kind of work. And that flaming explosion was kind of an early indication that artificial intelligence was going to run its course for its first computational decade, and then hit this thing called the AI winter. But the AI winter is over, and a lot of adjacent industries like finance and manufacturing and pharmaceutical research and agriculture are all using artificial intelligence tools and data to try to optimize their processes. All of these are very practical applications of these kinds of technologies in industries that can afford to invest in them. And we've had an early warning about this question of AI, at least in the professions. This book written by Richard and Daniel Susskind argued in 2014 that artificial intelligence combined with the internet does two things, that combination does two things that professionals do: reason about information and hoard it. And if the reasoning can be done by an algorithm, and the hoarding can be eliminated by the internet, then professionalism, the idea that we need these super experts who exercise their judgment, may well be challenged. And I agree with that thesis, but I think we're looking at it in the wrong way. And one of the reasons we're looking at it in the wrong way is that these tools right now are being deployed in ways that are bizarre and provocative and interesting, but in many ways not relevant to the problems that I've described earlier that are challenges of the building industry. But a lot of the work that Roger started back in the 70s around natural language processing has become the front end of the theory for how machine learning algorithms actually work, but in a completely different way than Schenck asserted. What these algorithms now do is they use high levels of data correlation, which allows you to do all kinds of interesting things like translate text sentences into images. So on the left, I play around a lot with this text image generator called DALL-E. On the left, somebody asked DALL-E, please generate a chair that looks like an avocado. Pretty convincing, right? Image on the right, I asked DALL-E, make me a skyscraper out of newspaper. Somebody said, make a doghouse for my corgi made out of sushi, and so forth. These are all fun. They're super interesting. They're also getting better. So Oliver Rainwright, the British architectural critic, asked an AI image generator to look at all of the serpentine pavilion solutions and generate a serpentine pavilion based on the images it could scrape from the web. And Wainwright said, the AI has created a kind of haunted, amorphous blob stuck in a perpetual feedback of its own making, which somehow seems fitting for our times. So I showed this article on my friend Mark Graves, who's a computer scientist who leads a lot of the government's work on artificial intelligence. And he said, Oliver Wainwright's money quote in that article strikes me as both bad computer science and bad architectural criticism, which I think sums up the problem of our current fascination with image generation, which is too interested in things that are only two-dimensional images, not interested in the real problems. When solutions to the real problems, the real problems, framed as I framed them earlier in this presentation, are not at hand at the moment. They need to be, but they're not at hand. Meanwhile, the image generation algorithms are getting much more convincing. This is this thing by this guy, Lavelcio, called a website that you should try called This House Does Not Exist. And you type in a sentence about a house, in this case, a modern curved wood and stone home in Kigali, Rwanda. And you get this thing that looks like a building, but it is not a building. There's no underlying understanding or ability to reason about this thing. It's an image. And so last week when I was preparing for this talk, I read this interesting article in The Atlantic. Some guy used one of these text to image generators, and he typed in, give me a detailed blueprint for how to build a beagle. And this is what came out. And you look at these things and they're kind of architectural. I mean, I've never seen a beagle drawn in elevation before, like right here. That's pretty cool. These look like some kind of unfolded plans. This is all gobbledygook. So it all looks very compelling. It's also completely meaningless. And to prove that point, I typed in myself to the same, it's into DALL-E, give me a detailed blueprint for how to build a library. And I got these plans, sort of, one axon, one really weird sort of Escher-esque axon here. And all of the text is Martian, right? Lubbly, bloppily, I don't know what that means. This is all garbage. Or it's not garbage. It's interesting, it's provocative. I'm giving a talk at an academic symposium in a couple of weeks where people are going to talk about the underlying meaning of this image generation and its potential for generating architectural ideas. That's fine. It's just not that interesting. And there's some experimental technology going on now to translate these 2D images into 3D solids. But even if that problem is solved, which is a really hard problem, there is still no innate understanding of what's happening here. There's no innate understanding of what's happening as a building. Now, there are other more banal but more provocative exercises going on. This is Insight 360 by my former colleagues at Autodesk, where they take giant data lakes of construction administration information and they use it to reason about construction projects, predict where there might be problems. This is Numetrics. It uses computer vision technology to identify safety problems on job sites. And there are other kinds of AI-based opportunities and threats. This one is an interesting one. I'm not sure whether it's an opportunity or a threat. This is a company called Upcodes I met a couple of months ago. They're making excellent progress on AI-driven algorithms that do code analysis of Revit models. Now, I don't need an architect to do the code analysis of a building. I can use an algorithm. I also don't need a code official, by the way, but that's a whole other discussion. That raises some super interesting questions about what the role of professionals are in the process of generating these buildings. More interesting, at least in my view, vectors are companies like my old buddies from the Revit team, Anthony Hauk and Ian Howell, who have this company called Hypar, where they're using artificial intelligence and generative design to record the knowledge of how, in this case, the Japanese Genkan Obayashi generates schemes for towers. No one's claiming these schemes are architecturally profound. They just solve problems. And in that, at least in my view, are vectors for what's happening. So if we're not going to make the same set of philosophical and religious errors that we made in the BIM transition, at least in my view, in this AI problem, what's the argument for how we want to attack AI? And that's really why I decided to pull this book together. And the book is organized in a very simple structure that looks at issues of process, how we work, issues of relationships, how we work together, and issues of output. What are the actual results of how we work? And you can see from my little sketch there on the right that I try to address questions of technology implication, agency of the players, project delivery, and value propositions across this set of arguments. And so I want to take you on a very rapid speed tour of how I kind of built this argument. So in the first section about process, I try to talk about the evolution of these different kinds of technologies from CAD to intelligent machines across a range of things that technologies now do in the building industry, whether it's represent an artifact that's to be built, try to predict its behavior, translate it into a physical artifact, or support the collaboration of the team that's working. And we've been drawing, on the left there is a floor plan from hundreds of years before the modern era. And on the right is an AutoCAD drawing from an airport project that I worked on. These are not fundamentally different phenomenon, but in this break between BIM and AI, I think we will see a series of transformational strategies. And one of the ways I tried to make that argument was to look at what I believe to be the progression from manual drafting to artificial intelligence across the ways that we reason about information, whether this is based on a taxonomy that's described in the book, an understanding taxonomy, where essentially our manual drafting tools were used for documentation. And then there's this potential progression of algorithmic capabilities, starting with understanding and ending with the ability to actually create stuff. And I think there's a route you can follow that we got to more precise geometry as we got better drafting tools. Then when we got into CAD, we could measure and scale things. Then when we got into BIM, we could start to do simple model analysis. Then as we get into later BIM, we have the potential of doing integrated analysis of multiple models. And as we get into the ability, as we add the capabilities of generative design, we can start scripting things. And then maybe we can script the generation of simple ideas. And then maybe there'll be enough data someday that those simple ideas can be generated in an unguided fashion by an algorithm. And then maybe sometime in the future, long after I'm gone, there'll be full autonomous design. But there's a long way to go to climb this ladder. And what I argue is it's going to require an evolution of both process, technology, and data infrastructure for us to get there. And I take a moment to sort of define in one of the chapters the difference between the software we're using today, which I call algorithmic, meaning it's all hard-coded. The early artificial intelligence algorithms that I call empiricist, because they empirically absorb tons of information and then try to reason about that information by correlation, but they don't know anything, to the next generation, which we're not at or anywhere near at, which I call cognitive technologies, where these artificial intelligence algorithms can reason causally about the world using common sense. I was listening to a thing on the radio this morning about these guys who've trained some human brain cells to play Pong, but they were comparing that with the fact that you can teach a 5-year-old to make a cup of tea, but you can't teach the best supercomputer on the planet how to walk into your kitchen and make a cup of tea. So we're really far, far away from these cognitive systems. And in the boundary condition between empiricist and cognitive is where I think we have to go. And in order to do that, we're going to have to develop a knowledge theory about what professional knowledge is and what its relationship is to the algorithms that we're going to apply. So I spent some time looking at different ways to define architectural knowledge, and then put forward 2 potential states of pre-AI versus post-AI evolution. That if the green box down below represents the kind of data that we're generating today, whether it's models or scans or analytical models, construction management data, building automation data, when that stuff if that stuff can be processed through next generation artificial intelligence platforms, we could get to some super interesting things like automating design tasks, or starting to explore problems with alternative generation, or automating things that happen on the construction site, or having buildings run themselves in a very interesting and potentially optimized manner. And that only happens, at least in my view, and it takes too much time to explain this slide to bother with it. But we only reach this kind of technological nirvana state where design is autonomous and buildings are built by robots and they run themselves with no human intervention. The only way we get to that is by going through a series of logical, strategic steps that we have to do explicitly as an industry. And we are really bad as an industry at doing this kind of stuff. We'd have to go from taking all that data, creating common data environments, figuring out delivery structures that make them work, then train a ton of these platforms so we have actual AI platforms, and that's a different problem. And then we might get to this nirvana state. The problem, of course, with nirvana is you've got to have a theory of what things the computers can actually do. So in this chapter called Scope of Services, I try to create a theory of different kinds of capabilities that you can see color-coded here, from understanding through creation, based on Bloom's taxonomy of teaching, and then apply those principles of what we do as professionals to our overall scopes of service. And I did this detailed analysis where I looked at where are the low-level tasks, where are the mid-level tasks, and where are the high-level tasks. And there's still a lot of very high-level tasks that I think it'll take a really long time for computers to actually be able to handle. So I went through and kind of categorized different things that architects and engineers and contractors do in a series of these categories, like ideation, technical production, client and management, and laid out different potential strategies for where AI might be potentially useful and augment our capabilities as designers and builders, but not potentially replace us. The problem, of course, is if we don't look at that problem through the lens of project delivery models, then we're just applying, we're following the same route that we did with BIM. We're just applying weapons to a war for which we have no strategy. And so in the second part of this, in the second part of my argument, I tried to unpack where that strategy might be in terms of the relationships between the players. And you have to start that argument by looking at what the value proposition is of the process, of the processes that we use to actually generate buildings, which is the kind of the nirvana state where what professionals do is they generate and synthesize complicated, ambiguous ideas. And what I argue in the second section of the book is that's really, really hard to do because it requires the ability to define and understand, predict, and then generate new kinds of ideas in a kind of three-step process. And those three steps are really, really hard to automate. And in fact, they're the kind of reasoning that's necessary to do important things, at least according to the guys that think about this problem, is really hard. I was heavily influenced by this book by the computer scientist Judah Pearl, who was the guy at UCLA who invented the concept of Bayesian networks. Bayesian networks were the first generation large data AIs. And what Pearl says in his book is, you don't have an artificial intelligence algorithm until it can reason counterfactually. In other words, until it can say, why didn't this happen? It can't imagine things or understand things. And we are nowhere near having technology that can reason counterfactually. And so as a consequence, the systems that we use to prepare people to go into our professions have to anticipate this idea that these algorithms can do certain kinds of things that are lower level on the hierarchy of understanding, but require different kinds of knowledge and different kinds of reasoning. And then I make the kind of additional argument that the structures, at least in architecture, and this book was written for REBA, so I'm constantly comparing things happening on two sides of the Atlantic. These structures of certification, licensure, education, very slow on the uptake, and that this process, the evolution of this technology may happen faster than the industry structures can accommodate, and that's a danger. So in the third part of the discussion, those of you who know some of my earlier interests know that I am really interested in this idea of changing the models of delivery out of commoditized selling for lowest price and getting to results. And that was one of the original theses that we put forward when we were making the argument at Autodesk for BIM. We said, look, not only does this thing relieve you of your obligations to do production, it gives you the ability to predict outcomes and therefore do a better job for your clients. And so I wanted to refract that argument through the possibilities of artificial intelligence. And so I looked at that as the first thing you have to do is say, okay, what are the outcomes that we're trying to get to? What capabilities do we need? And what data do we need to train the AIs to do that? So I looked in chapter 3.1, I looked at a whole series of what I thought were significant results-based processes that we need in the building industry, from zoning to space coordination, carbon, cost, supply chain, a whole series of problems, and said, if we had this capability, what data would we need in order to drive these kinds of results? And it became apparent from that argument that there are three large-scale inhibitors to the problem of creating an artificial intelligence environment in the building industry. The first one is our lack of ability as an industry to organize our thoughts coherently in order to direct the development of the technology. That's problem number one. Problem number two is these algorithms need enormous amounts of data, which we don't have access to. And so what I argue in chapter 3.2 is not only do we need to decide strategically what we're doing and figure out how to take that data described in the upper diagram and use it, we're going to figure out a place to organize it. And I proposed this idea of an industry data trust, which I worked out with Mark Graves and a couple of other folks in another paper that we published a couple of months ago, that the building industry not only needs to organize itself strategically, it's got to find some place to put all this data so we can get and anonymize it and curate it, deal with the risk issues, so we can actually train these things. But the third problem, which is kind of the conclusion of the argument, is we have to be strategic in a way that these kinds of algorithms don't make the easy parts of the design and build process so rote that our value as professionals is essentially eliminated. And this is a pretty tricky problem, because if the gateway drug for the necessity of professionals is licensure and the standard of care, and the standard of care as a definition is under attack because its basic fundamental characteristics can be delaminated by AI, we've got to start figuring out how we're going to use these technologies to automate and augment our capabilities as designers and builders and not eliminate them. And it's a tricky problem, because when you start looking at the economics of labor, at least on the design side, this is a graph that I generated from data in the UK, the production value of construction continues to accelerate over time, but the number of architects it takes to do that work decelerates. And while this would require a much more detailed peer-reviewed study, that decline that you see there starting in 2018 coincides almost exactly with the UK government's level 2 PIM mandate, where 40% of the projects built in the UK were going to have to be done using building information modeling. So you got that productivity boost. And I just use this as an example of having to attack this problem of efficiency and being automated out of a job. And the problem, of course, is it's very easy to get automated out of your job if your value proposition is based on your lowest first price. And so in the last chapter of the book, what I suggest is we can use these kinds of technologies and combine them with the opportunities of the larger problem of building to change the value proposition from heavily commoditized lowest first cost to a different value approach, a different set of different set of business models. And in that chapter, I quote this book by Charles Johnson, who's a professor at Georgia Tech, who wrote a really amazing book called Assembling the Architect, where he talks about the evolution of professionalism in the United States. And he does so by reading quotes from this kind of screed written by a local architect outside of Chicago, whose alter ego was an architect named Tom Thumbtack. And he wrote this book called Architectonics, one chapter of which was all about this problem of fees. So I've written about this problem before, and I want to talk a little bit about what I think the strategy might be for these alternative value propositions. And what I've argued is our value propositions in the building industry are largely disconnected from the business models that we use to deliver them. That our clients and owners build buildings that are for highly aspirational purposes. They build buildings to do things. And our value propositions in the building industry are largely mired in what I call transactional outcomes, like delivering on time, delivering on budget, making sure the energy costs are met. And the problem, of course, is that the value of the value pyramid is inverse, right? There's much more value in delivering an asset that achieves a client's aspirations than there is delivering an asset that just meets budget and schedule. But our delivery systems are so locked into those lower level outcomes, it may be that these new kinds of technologies give us an opportunity to break out of that. And if we were going to do that, we would start looking at a theory of outcomes that we could get to progressively on two axes. The lower axis, the x-axis being sort of from transactions to aspirations, and the y-axis being collaboration. And there's clearly here a subtext of integrated collaborative delivery, which I think is the subject of a whole other conversation, but is in combination with some of these technologies, maybe some of the secret sauce. And what I've argued is the value, if the value to our clients accelerates rapidly as we move from left to right on this graph, that as designers only, all we can do is optimize our transactional performance. If we include our builder collaborators, we can optimize what I call executional performance, like making the projects work on budget and on schedule and meeting their specs. If we include our clients in the problem, we can get to asset operation results that are much better around energy and carbon. But where we really want to be ultimately is being able to say to clients, this project we are building for you does these things, and we are willing to commit to these things. And if these things happen, we want you to pay for them. This is Howard Ashcraft's incentive compensation layer theory on steroids. And the thesis here is, if we can get ourselves together in a coherent way and begin to deploy these technologies in a strategic way, we can move from left to right on this outcome taxonomy and begin to deliver much more value to our clients and the people that we build buildings for. But we have to build delivery systems and value propositions that sort of make that conversion. And I just want to touch briefly on an example that I used in class, in our modern slavery class on Wednesday of this week. I was asking our students, what would need to happen to change the following construct? I was using the example of the building that we were sitting in, which is a Paul Rudolph designed building with a Charles Gwathmey addition that is enclosed in a zinc paneling system. And the question I asked our students was, what can you do as an architect when you make a sketch like this one on the left that prevents this child in this zinc oxide mine in Peru from being enslaved? Because you made that decision about zinc. It went through this progressive series of refinements and further decisions and cost estimation and installing. But really, when you chose to put zinc on this building, you enslaved this child in Peru. What can you do about that? How do we disrupt this system? And what we know from some of the work that's happening in manufacturing, for example, is artificial intelligence algorithms are being used to evaluate supply chain relationships, shipping manifests, bills of materials, economic data from government agencies, putting together very complex sets of relationships. So when this project had started, if Yale University had said to Charles Gwathmey and his team, you better make sure there are no enslaved laborers producing anything on this project, how would we attack that problem? And for me, it's a proxy for this new perspective that we need in the building industry to do a better job. Pick your issue, whether it's climate change or social justice or life safety. The problems are more complex than the tools that are currently available. And so in the conclusion of my book, I basically said, I made two arguments. One, if you don't have a strategy for what you want the technology to do, I say this with all the love in my heart as a former vendor, the vendors will do whatever makes the most money, which may not be in the best interest of the industry. So therefore, point number 2 is we need to organize ourselves as an industry and do 5 things. Guide the definition and creation of these technologies by telling the vendors what we want and supporting and helping them. Expand the remit of the design, and in this case, construction process, to include performance through changing project delivery models. We're going to need to create the data infrastructure that can train these things so they can be useful. And we should use that data infrastructure and these tools to refactor the relationship between the pieces of the process, looking at those things in a systematic way, in the same way that I just argued, you have to look at the labor supply chain in a systematic way. And in doing this, we can combine these technologies with these ideas about value proposition, and we can shift the value propositions of design and construction. And so that's, I know that was an intense fire hose there, but that is essentially the argument. So with that, Margie, I guess we can try to take some questions.
Let me pop in and ask a question. The Center for Innovation was one of the first organizations to talk to the people at Grace Farms about their work at responding to slavery within the supply chain. They've obviously made a huge amount of progress over the last 2 or 3 years at sort of educating the industry.
Yep.
I'm wondering, from your perspective and working with the students that you are, what do we think the trajectory is as to the amount of time it's going to take for the industry to be aware and integrate the principles beyond elimination of slave labor into the design and construction process?
At least a decade.
Yeah.
At least a decade. So when I left practice in 2000 and became a vendor, right, joined Autodesk, and then I got caught up in the whole sort of biological cycle of technology innovation. It took me a decade to realize that cycle is incompatible with the change cycle of the building industry. It takes, for anything interesting to happen in the building industry, it takes at least a decade. At least a decade. And that's if we're working at it. I mean, think about we will stipulate that there was a really interesting run up to 2002 with BIM. And 2002 was the moment at which the primary technology provider to the building industry, Autodesk, decided to move in that direction. It's 20 years later. People are using the thing, but they're mostly using it to draw stuff.
Right.
So I'm kind of, bummed about that.
Okay, well, let's see. I'm going to just pull questions from the chat box. We have a question here from a center board member, Zig Rubel. How do we educate and implement aspirational performance factors, vertical 4 in your diagram, to both profession and ecosystem?
Well, I wrote a little bit about this in my previous book. I think that this value-based performance strategy is kind of like going to the gym. We can't start on the right of the diagram. We need to start our value calisthenics on the left-hand side of the diagram in the first 2 blocks, right? Where we are going to have to demonstrate to the industry through an intelligent use of technology and collaboration that we can do a better job than we're doing right now. And I think that's table stakes to moving on, right? My friend Scott Simpson used to say, architects like to preach change about everything except their own profession. And we will also say to a client, this project's going to be great. It's going to be beautiful. It's going to work great. It's going to save energy. It's going to be great. But there's nothing mentioned about that in the contract. The contract mentions things like budget and schedule, and we're not even very good at that. So I think Zig, we have to start there and work our way up that particular ladder.
Interesting. So we have a question here from Chris Vernon. Your argument that owners and clients have primarily aspirational goals in mind doesn't seem accurate to me. While an architect may raise the connection between zinc and slavery or concrete and climate, most consumers ignore these connections and impacts in their day-to-day lives. How and why do you expect owners and clients to be any different?
Well, I, as someone who has been both a client and an architect, I'm going to take exception to the first half of that argument. Clients don't build buildings to be on budget and on schedule. We built this building to educate architects. My boss, the dean, is building a lab for Yale right now to advance human knowledge. Those are aspirations. But I think the second half of the argument is exactly right. So I will suggest to you a different way of looking at it. My teaching colleague, Lou DeBaca, was the former ambassador in the Obama administration for modern slavery. He started the forced labor group in the State Department. He also wrote federal legislation, which is in place right now, making it illegal to bring anything into this country that was produced by forced labor. So if we were building that building, if we were building the Gwathmey edition right now, and I could demonstrate to the border protection people that zinc came from Peru, it wouldn't be allowed into the country. And now I have no zinc. So it's a combination of, I kind of look at it in two ways. On the one hand is the TIFT legislation that makes it illegal to bring this stuff in. At the other end of the extreme is what I call the plastic straw problem, right? About 2 years ago, somebody, in order to sell paper straws or whatever, somebody made the argument that plastic straws were really bad for the environment. And plastic straws represent nothing. But when was the last time you saw or used a plastic straw? You know, it's the same argument that forced developers to start building LEED buildings because their tenants wanted to be in environmentally responsible buildings. One of the projects we're working on now with Bureau Happold and Kieran Timberlake is an embodied slavery modeling calculator that will look at your model, identify where potentially problematic materials are, and also compute the value potentially of the externality of slave labor. So in other words, in my zinc example, if this is research, we haven't done this yet, but in my zinc example, if the modeler says, well, if you bought your zinc from this French supplier, it has 0 enslaved labor and it costs X. If you buy it from this Peruvian supplier, it costs Y, much cheaper. The delta is the cost of the enslaved labor. So your project has X thousands, $100,000 of externalized suffering in it. That should get people's attention.
Yeah, we'll be very interested in hearing about how that research continues because we've been following this issue for quite some time and are really interested in how we might educate the industry about this.
It is a deeply non-trivial problem.
Yeah,
because the supply chains are incredibly opaque.
Right. We have a question here from Quang Chong. It says,
by the way, he's one of my former students.
Well, okay, so you're going to really like his question.
I can read
Thanks for this incredibly high level and organized thinking regarding the future of the profession. I'd like to hear you talk about what you think are the next most immediate steps to promote change and the development of innovation in the building professions. How do we guide the definition and creation of technology? We at the center hear a lot of people trying to solve problems that aren't really problems. So, so we hear a lot of people, we think, that's not really a problem we have, but good luck to you. So I think it's a great issue that you raise, Con.
Well, I think that these kinds of these changes always happen in two directions. There are individual innovators creating provocations, and then there's industry-wide efforts. And so what tends to happen is a phenomenon on two sides of the Atlantic Ocean, in my observation. On our side of the Atlantic Ocean, there's all kinds of innovation and no place to take it because the industry does not have any platforms. On the other side of the Atlantic Ocean in the UK, where I'm going next week, there's lots of committees and multidisciplinary white papers written and platforms to discuss the problems, but nothing, they don't actually do any of the work. They don't actually do this stuff. So we need to take the ability of Americans to provoke change and the ability of Brits to get themselves together and to speak as a whole, as an industry, and combine those two things. Because this is, it doesn't matter. You couldn't possibly in your lifetime collect enough data to train an AI to do anything. right? So if we're going to really leverage this, if we're going to do anything about this, we as a U.S. construction industry are going to have to get our act together. And so there are kind of interstitial organizations like yours, but look, I'm a believer in the power of the government to make change, which I know politically is, I might be at odds with some people, but wouldn't it be great if we had a secretary of construction who could convene the industry and help speak for the government to help the industry speak as one voice? But I mean, how long have we been working on a national BIM standard? My grandkids are going to have grandkids before that thing is done. So I think there's a lot of work to be done. A lot of work to be done.
Phil, it has been so wonderful to spend the last hour with you, but unfortunately, we're sort of coming to the end of our time. I hope you'll come back in a year and tell us where your research has now led you. And I'd really like to invite everyone to make sure to buy a copy of this book. I believe you can get it on Amazon or at your favorite bookstore. Is that correct?
I don't know. I don't know how much market penetration Reba has in bookstores, but
they'll special order it for you, at least around here in the Bay Area. So please be sure to get a copy of it. It's really, as I said, it is actually really terrific beach reading if you're an intense person, but there's so much more detail into what Phil presented today that I really encourage you to go deeper in it, because it's really a fascinating study. So thank you.
Thanks. This question that Mark asked in the chat should be the subject of an entire discussion, because that's a whole, I do write a little bit about that in the book, but that's a whole other vector, like bad algorithms, which we're already seeing.
Yeah, right. Thank you again, Phil. It's really great to have you. Like I said, we'd love to have you come back, maybe in the next year or so. Today, we're going to now conclude this Center for Innovation event. Please mark your calendars for our next webinar on October 28th, entitled Discussing Design to Value with Bryden Woods' Jamie Johnson and Professor John Dyson. So to Phil's point, we have a British company, which is now opening up an American outpost, if you will, who's coming here. So perhaps we'll actually be able to do that across the pond collaboration you were talking about.
Excellent.
Yeah, you can register for any of these webinars or to stay in touch with us at the centerforinnovation.org website. The recording of this session will be placed on YouTube soon, and we invite you to share it with your colleagues. Thanks again to Phil for a terrific presentation, and to all of our sponsors who make this possible, and to you, our community of innovators, for all that you are doing to transform our industry and create a better world for all. Thank you again, and see you soon.